Spring force definition. Spring force is a restoring force exerted by a compressed or stretched spring, seeking to return it to its equilibrium or rest position. It is a fundamental concept in physics and engineering, playing a crucial role in various mechanical systems. 1. Nature of spring force. Restorative property. Springs exhibit restorative behavior, opposing any deviation from their equilibrium position. Proportional to displacement. The force exerted by a spring is directly proportional to its displacement from the equilibrium position. 2. Hooke's law. Mathematical representation. Hooke's law describes spring force as F equals kx, where F is the force, k is the spring constant, and x is the displacement from equilibrium. Linear relationship. The force applied and the displacement are linearly related, assuming the material stays within its elastic limit. 3. Spring constant. K. Definition. The spring constant represents the stiffness of a spring and determines how much force is needed to produce a certain displacement. Units. Expressed in newtons per meter, N/m, in the C system. 4. Types of springs. Compression springs. Compressed springs exert force when compressed. Tension springs. Stretched springs exert force when stretched. 5. Equilibrium position. Balanced forces. At the equilibrium position, the spring force equals any externally applied force, resulting in a state of balance. 6. Potential energy. Elastic potential energy. When a spring is stretched or compressed, it stores potential energy, given by P equals 0.5 kx squared. 7. Applications. Mechanical systems. Used in various mechanical devices like car suspensions, door hinges, and shock absorbers. Engineering. Crucial in designing systems with oscillatory or vibratory motion. 8. Damping effects. Dissipation of energy. Spring force can be affected by damping forces that gradually reduce the amplitude of oscillation. 9. Oscillatory motion. Harmonic motion. Springs contribute to the harmonic motion observed in systems like pendulums and vibrating structures. 10. Limits of Hooke's law. Elastic limit. Hooke's law is applicable within the elastic limit of the material, beyond which permanent deformation occurs. 11. Factors affecting spring force. Spring material. Different materials exhibit varying spring constants. Coil configuration. The design of the spring, such as the number of coils, influences its behavior. 12. Practical considerations. Fatigue. Repeated loading and unloading can lead to fatigue and eventual failure of the spring material. Temperature effects. Spring behavior may be affected by changes in temperature. 13. Conclusion. Foundational concept. Understanding spring force is crucial for engineers and physicists dealing with mechanical systems, providing insights into the dynamic behavior of materials.